This is Differential Equations, section 6.1. So in this section, we're learning about the Laplace transform. So in math, there's generally things that are elements, like little things. And then there's functions that move around elements. And then the things that move around functions are called transforms. They're functions of functions. And saying functions of functions is awful, so we call them transforms to kind of help ourselves keep things straight. So the Laplace transform is actually a linear transformation, which is fun, especially for those of you who have taken linear algebra. And so for those of you who have not yet taken linear algebra, when you hear that word linear transformation, Laplace transform is one of the things you can think about. So it's transforming one function into another. And you might say, in kind of a painful way it's a lot of work to figure out what function things turn into sometimes. But it's useful when we have no idea what's going on. So there's certain differential equations we can only solve by doing a Laplace transform. So here we go. So on the top here, I've got the definition of the Laplace transform. And so you really need to keep track of what placeholders are here. So the Laplace transform, which is like, I write a fancy L, kind of starting from the top, and then of f. So this thing, fancy L of f, that's the new function. And then we know functions, functions like people are known by their actions. So like, what is a function? In order to say what is a function, you have to say what it's doing with s. Well, it's taking s, and for each s, it's computing this integral. Well, that's fun. And so integral from 0 to infinity, e to the negative st times f of t dt. Okay. And we'll call that function capital F. And so this is a notation that's not, like, be careful with it, but it helps us keep things straight as far as, like, capital F is the Laplace transform of little f. And we'll do that with, like, Laplace transform of little g is big G and stuff like that. That'll help us keep things straight in our heads. So activity 611 part A gives us a really mean function for part A, that is t to the 6th power. So t to the 6th power, well, that means you take t to the 6th and put it in where the little f is. And take the integral, find out what you get. Well, that's an awful integral, because consider this. So then if f is that, then we'll do our fancy L of f of s is equal to the integral from 0 to infinity of, I'll write the little f first, t to the 6th times e to the negative st dt. Okay, so it's an integral with regard with the dt, and I've got an s in there. So once I take the integral, I'll have an expression with only s and numbers. It should be a function of s. Now this is an awful integral, because in order to do this integral, you need to do integration by parts 6 times. So let's not do that. Let's use an integration table. You guys have passed Calc 1 and Calc 2 and Calc 3. So now I trust you to use an integration table to save yourself some time. Okay? So this is the integration table we're going to use. An integral from x to the n, e to the ax is this. So instead of x, I have t. Instead of a, I have negative s. So then I'm just going to apply this 6 times, which is a little bit less work than doing integration by parts 6 times. So it's x, so t to the 6th, e to the negative st over a, which is negative s, from 0 to infinity and that term's going to be 0. So if I plug 0 in, then t to the 6 times 0 is 0. Okay, so 0 to the 6 is 0. And if t goes to infinity, this term will overwhelm that term. How do I know that? It's similar to a Calc 2 thing I assigned to you guys way back in Calc 2. So maybe just trust me. All right, so minus n, which is 6 over negative s, times the integral of t to the 5th e to the negative st dt. Okay, let's keep going. So this equals, well, that's 0, so we'll forget about that. And the negatives cancel out, so negative negative is positive. So then we'll have 6 over s, and we do it again. So now I'm doing t is x, and n is 5, and a is negative s. So I've got t to the 5th times e to the negative st all over negative s from 0 to infinity. And let's see, minus 5 over negative s times integral t to the 4th e to the negative st dt. Okay, well, let's simplify. That is 0 again, and that's a 5, and that's an s in case you can't read that. Yikes. Come on. All right, and then, so then, that's 0 again, and negative is positive. So simplify to get 30 over s squared times the integral of t to the 4th e to the negative st. Okay, well, let's keep on chugging. So that's equal to 30 over s squared times, hopefully you're getting the pattern now, t squared e to the negative st all over negative s from 0 to infinity minus 4 over negative s times integral t cubed e to the negative st dt. Okay, that's 0. Negative and negative is positive. So 4 times 30 is 120 over s cubed times integral from 0 to infinity, which I might have forgotten in some of these. 0 to infinity, 0 to infinity, 0 to infinity. Okay, 0 to infinity of t squared e to negative st. We're getting there, dt. Okay, so then this is 120 over s cubed times t e to the negative st over negative s, 0 to infinity, minus 3 over negative s, integral 0 to infinity, t e to the negative st. Oh, guys. Oh, no. What did I do? This is cubed, which is all the same there. And that's squared. Okay. Right, because I've got 2 to the 4th, t cubed, t squared. That was t cubed, t squared, t. We're okay. We are okay. All right. So negative is positive. So 120 times 3 is 360 over s to the 4th times integral t squared e to negative st dt. Okay, yeah, we'll have to move on to a second piece of paper here. So that's 360 over s to the fourth times, let's see, it seems it's always good to double check the work. So it started to the fifth, and then I factored that, and I did kind of two steps at once there. So to the fourth, cubed, squared, simplified, because it's x to the n minus 1, x to the n minus 1. These should be higher than that. This is t to the sixth. This is t to the fifth. Maybe that's just me misreading my own handwriting. Fifth, make this t to the fourth, which makes this t cubed. Okay, so then integrate that, and you get t squared e to the negative st over negative s, 0 to infinity, minus 2 over negative s, integral 0 to infinity. Can you see this? You can barely see it. Okay. Times t e to the negative st dt. Okay, now let's use the fact that the book already did one of these integrals already. They did in example 1, example 611, part 2. They did e to the negative st times t and got 1 over s squared. Okay, so that means that this term right here is, not including the scalar, is 1 over s squared, because that's already been done. Okay, so then our final term then is, so negative and negative is a positive. 360 times 2 is 720. 720 over, so I've got s to the fourth, s, so it's s to the fifth, s to the seventh. All right. And there's a better way to write 720. It's equal to, you can also write that as 6 factorial over s to the seventh. Okay. So that is our answer. That's the Laplace transform.